Hey, welcome to Number Club. This is Year 1 Pure, Chapter 2, Lesson 1. Today we're going to be factorising and solving quadratics, and we're going to be using the quadratic formula. If you can't remember how to factorise quadratics, you need to go back to the previous chapter to have a look at the lesson that is about factorising. So let's get cracking. So this first question has a quadratic equal to a linear. We've got x squared plus 4x minus 13 is equal to 2x plus 2. You shouldn't do anything with this until you have equals 0. The reason is, if you try to factorise this quadratic, aside from the fact it doesn't factorise, once you do that, you'll have just two brackets equals a linear. It doesn't then produce something really nice and easy to solve. It doesn't do anything useful for you. What's actually going on here is we've got a quadratic that looks a bit like this, where that would be negative 13. Okay, and we've got a linear that looks like this, where that would be 2. It's obviously not very accurately drawn. And we've got two solutions for it, okay? Those two solutions exist here and here. It might well be that this line should have intersected above the x-axis. We're not sure just yet. But we're trying to find out where do those two things equal to each other. So let's find out. So we've got x squared plus 4x minus 13 equals 2x plus 2. Let it equal 0 by taking away 2x from each side and taking away 2 from each side. You get that. This is an easy quadratic to factorise. I'm not going to talk you through that. You need to go back to one of the previous lessons to find it. Okay, it's not overly complicated though. And we get two solutions, two unique solutions, because there's two brackets. Now, if we're saying that those two brackets multiply to make a 0, imagine we had 8 times mystery box equals 0. Well, that mystery box is clearly 0, isn't it? 8 multiplied by 0 equals 0. Even if it was 18, or 918, or 1918, or 21,918, if you multiply it by 0, you get 0. So to produce this 0 here, they're either both the same and they're both 0, or one of them is 0. So the solution 1 is when x plus 5 equals 0. X equals negative 5. Okay, just solve that. X equals negative 5. When x equals negative 5, we get one of our solutions. Solution 2 is when x subtract 3 equals 0, x equals 3. That's another value. When we plug in 3 into this, for example, we'll get out the same as if we plugged in 3 into this. If we plug 3 into this, we get 8. Plug 3 into this, we get 8. Okay. Plug negative 5 into this and you'll get negative 8. Plug negative 5 into this and you'll get negative 8. All right. In actual fact, those 3 and the 5 actually represent vertically where do those solutions happen. Okay, they're not the x-intercept of the quadratic, nor are they the x-intercept of the linear. They represent vertically where do those intersections happen. Okay. Now this question here is really commonly seen and very poorly done. If we're looking at x squared equals 5x, the problem is that sometimes people decide to divide through by x. And this is not a good idea. To divide through by x, you end up with x equals 5, and it looks like you get your solution. Great. But no, you've actually lost one of them. Let's talk about which one it was that you lost. What I said on the previous question was that you should let your quadratic equal 0. We'll factorise, and you get two solutions. One, if x is 0, it doesn't matter what this bracket is. You can treat that if you want to. I know some people find it a bit easier to think of it as being x plus 0. It doesn't really matter though. X equals 0 is one of the solutions, and the other one is where x is equal to 5, because 5 take away 5 is 0. So you've actually lost by doing this method, the x equals 0. And if you look at it, 0 squared equals 5 lots of 0. And if you look at what you divided out, it was x. X being 0 is getting lost there. Don't try to be too clever with these quadratics. Let them equal 0 and then just do the job. Okay, moving on. This quadratic's a little bit more difficult because it's got a 3x squared. So let's deal with it. We've got 3x squared plus 5x minus 2 equals 0. Again, look back onto the previous lessons if you can't remember how to factorise. But in this case, we've got two numbers that we're looking for that will times to get 3 lots of negative 2, which is negative 6, and add to make 5, and they will be 6 and negative 1. 3x squared plus 6x minus 1x minus 2 We'll factorise both sides. So we get 3x lots of x plus 2 and minus 1 lots of x plus 2. Okay, the quadratic actually ends up looking like this. 3x minus 1 equals x plus 2. 3x plus 1, pardon me, multiplied by x plus 2 equals 0. And so you get two solutions again. Solution 1 is 3x minus 1 equals 0, x equals 1/3. And the other solution, solution 2, is x plus 2 equals 0, x equals negative 2. All right, so there's my two solutions. If you get given a question where you've got just from here you need to solve it, fine, just factorise it and solve it. If you're given a question where at the end of it you might have, say, x plus 3, lots of x plus 3, well then solution 1 would be x equals negative 3, solution 2 would be x equals negative 3. You just get one solution in that case, okay? And you're going to get used to dealing with one solution and two solutions really often. All right, quadratics can also have 0 solutions, but it's not really involved in this bit just yet. All right, we've got 2x plus 1 all squared equals 9. Now the inclination for a lot of people would be to expand out those brackets, move the 9 over, and then factorise from there. That's fine. If you really, really want to, that's absolutely fine. But if x just appears once, make it the subject. Make it the subject of the equation. Because you can do that if it just appears once really easily. 2x plus 1, opposite of squaring is to square root. When you square root 9, consider the positive and the negative. The square root of 9 is 3, true. But the square root of 9 is also negative 3, because negative 3 multiplied by negative 3 makes 9. Okay? And so we've got 2x plus 1 equals plus or minus 3. 2x is equal to negative 1 plus or minus 3. X is equal to negative 1 plus or minus 3 all over 2. So you get solution 1 and solution 2. Solution 1 is when x is equal to negative 1 plus 3 all over 2, which comes out as x equals 1. Okay. Is that true? Does 2 lots of 1 plus 1 and then you square it, does that make 9? Yeah, it does, works fine. And the other solution is when x is equal to negative 1 minus 3 all over 2. Okay, which is going to be x is equal to negative 2. Is that true? Negative 2 times 2 is negative 4, plus 1 is negative 3, squared is 9. Fine. Okay, we've got our answer. Now this question here, it looks really, really difficult, but always have a look at the coefficients. Always have a look at the coefficient of x squared, the coefficient of x, and the coefficient in the unit part. If they all divide by the same thing, you should do that, because you're either going to get something that's much easier or a little bit easier. It can't really go wrong. So we're going to divide through by 2. Okay, and we'll get that. The other thing is, if you've got a negative x squared or a negative 2x squared or a negative 3x squared, it actually helps to multiply through by negative 1 to change every single sign, because more often than not, you're going to get an easier factorise out of that. Okay, it's the exact same values that you're going to get. This would look a bit different to this, but the solutions will be the same. Okay, this quadratic here will look something like that, and this quadratic here will look something like that. But crucially, the solutions are in exactly the same position. Okay, one of them's happy and one of them's sad. You've got a smiley face and a sad face. All right, to factorise this, we get x minus 3, x plus 2 equals 0. And so your solutions are x equals 3 and x equals negative 2. Okay, let's move on. Now, the next question, this looks pretty weird, because the thing that I've asked you to do is to always try to let it equal 0. But really, you should try to deal with things like roots very, very, very early, so that you have just stuff that looks like the things that make up your quadratic, that you can then manipulate, and then you can do whatever you need to do with it. Now, we'll have a little look at this one. We've got x equals the square root of 5x minus 2. Now, what I'm going to do is square both sides. So I'll get x squared is equal to 5x minus 2. Now we know that x squared minus 5x plus 2 is equal to 0. So let's check if it factorises. Does it factorise? I need two numbers that will multiply to make 2 and add to make negative 5. Can you think of any that will do that? No. Doesn't factorise. Okay? And there are some people, I've taught a lot of people, and there are some people that don't even try the factorise, they just go straight on to doing what we're about to do, which is the quadratic formula. The quadratic formula is dead easy to use. It looks like this. We've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it looks really difficult, but it's dead simple. The coefficient to x squared is a. In this case, a equals 1. The coefficient to x is b. Make sure you include the signs on these as well. B equals negative 5. And the coefficient in the linear part is just c, or the constant part, pardon me, is c, which is 2. Okay? Now we're going to substitute those into the quadratic formula thing. So we've got x is equal to, we've got negative of negative 5. Watch out for that. Negative 5 will equal 5. I like to tidy these things up pretty early, even before letting the calculator give it a go. You can, if you want, let the calculator do most of your work for you though. Negative 5 squared is 25, minus 4 lots of 1 lots of 2, which is going to be 8. So I tend to just write these things in pretty much straight away. You don't have to, you can just work them, you can just chuck them into the calculator if you want to. And so what we end up with is x is equal to 5 plus or minus root 17 all over 2. And if we want a decimal version, we'll chuck that into our calculator. The thing is, if you're asked for an exact value, exact solutions, they are the ones that include the root. So the exact solutions are x equals 5 plus root 17 over 2 and 5 minus root 17 over 2. Those are exact because root 17 is a third. And wherever you round it, if you round something, you've no longer got an exact version of it because there was still some more stuff to come that would have made it more exact. So you can't be more exact than exact. Okay? So if we've got something that's rounded, like for example, the first answer comes out as 4.56 to 2 decimal places, or to 3 significant figures, to 2 decimal places, that's not exact because it would have carried on. It goes 4.56, 155, 28, 13, and would have carried on forever and ever and ever. But this is exact, and so sometimes you'll be asked for exact solutions, and sometimes you'll be asked for the ones that give you the answer to 2 decimal places. The other answer is x equals 0.44 to 2 decimal places as well. Okay, so there are 2 solutions, but they're not immediately obvious to get because you have to use the quadratic formula. As I said, some people just jump straight to the quadratic formula, and some people prefer trying to factorise and then dealing with the quadratic formula. It's up to you. All right. Here's a question from an exam. I couldn't really find a great question for this because it's still quite early into the course, but this question's got a cubic. I wouldn't normally introduce cubics at this point, but it says factorise completely. We can factor out the x from this cubic, x squared plus 10x plus 25, and we can factorise this bit here. Now the factorise for that bit, 2 numbers that multiply to make 25 and add to make 10 are going to be 5 and 5. X squared plus 10x plus 25 is actually a perfect square. Okay, that would be x plus 5, lots of x plus 5, which we can write like that. Okay, we've got x, lots of x plus 5, lots of x plus 5. That's the factorise completely, or x lots of x plus 5 all squared. Okay, the solutions will come from each of these brackets. One will be where x equals 0, the other will be where x plus 5 equals 0, so x equals negative 5, and similarly there's another one where x equals negative 5. Tend to write them all, negative 5, and 0, or just write negative 5 and 0. It doesn't really matter, okay, as long as your working's clear enough. Alright, thanks very much for watching. Visit numberclub.org to find some more videos and tasks, and if you can, like and subscribe to the video or to the channel, then hopefully this helped. Thanks very much.